as it is evident, this question is from quadratic equations. It says if alpha and beta are the roots of the equation ax square plus bx plus c, find the value of 1 upon a alpha plus b plus 1 upon a beta plus b. Now, if you add the two equations, taking the LCM, now you've reached this stage where you need to expand this term. So how will you expand the term? You can expand the term as a square alpha beta plus ab alpha plus ab beta plus b square. Okay. Now, if you expand it this way, of course, b square is taken separately. From these two terms, you can take b common. Okay, so you could take b common from here. So you're left with a alpha and a beta inside the bracket. So in fact, you could take a common as well. And then you're left with a square alpha beta. Right? So what is alpha plus beta here? Alpha plus beta is the sum of roots, and alpha into beta is the product of roots. So this is an extremely important concept applicable to quadratic equations. So if you proceed further, you will realize that this thing of sum of roots, this concept of sum of roots can be applied. Okay, so this sum of roots will get applied here and here as well in the denominator, and the product of roots gets applied here. So you have a times minus b by a plus 2b upon b square plus ba minus b by a plus a square times c by a. Okay. Now you will notice that here this term a cancels with this a in the denominator. So you are left with minus b square, which cancels with b square. So what are you left with? Essentially, this a square also cancels with a. This a would cancel with this a. So basically, you're left with minus 2b plus b, which is b, and you've got ac in the denominator. So that's the answer, which is b by ac. Okay. Now, let us look at if there is any other way to solve such questions. So typically, when you're given values like alpha, beta, and the equations are given to you, and you also know what you're supposed to find, if you can assume simple numbers for the roots like 2 and 3, if 2 and 3 are the roots of an equation, obviously the equation would be what? The equation would be x square minus 5x plus 6 equal to 0. Right? So if you substitute the corresponding values and try to figure out the expression, you could still arrive at an answer which is unique out of the options that are available. So let us find that out. Okay, so is there any other way to solve this question other than, using the traditional algebraic method? Yes, there is, which is to assume values of alpha and beta. So if you assume values of alpha like 2 and beta is 3, what would the equation turn out to be? It would be, the roots would be 2 and 3. So therefore the equation would be x square minus 5x plus 6 equal to 0. Now, in the context of what we have here, we have got a to be 1, b as minus 5, and c as 6. Right? Along with that, we have got alpha as 2 and beta as 3. Fair enough? Now, let us just substitute this set of values in this expression to arrive at the answer. So you've got 1 upon a alpha. What is a alpha? 2 plus b, which is 2 minus 5, plus 1 upon a beta. What is a beta? A beta is 1 into 3. So therefore 3 minus 5. So therefore you have minus 1 by 3 and minus 1 by 2, which is effectively minus 5 by 6. Okay. So if you continue substituting the values and try to see whether they match with the options, you have A upon BC. So what is A? 1. What is BC? Minus 30. Does this match? No. What about the next one? Yes, it does. You've got B as minus 5 and AC as 6, which is what is expected. What is the third one? C. What is C? C is 6. 6 upon AB. What is AB? AB is minus 5. And what's the last one? 1 by ABC. So what's the multiplication of ABC? It's minus 30. So 1 by minus 30 is also ruled out. So therefore the answer is option 2. Now, this method of solving is much more efficient than going through it step by step. So you could work out the solution both ways. Okay.